Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So I pulled my dump trailer into the garage for some maintenance. I like to try and take care of my stuff. I feel like, if you take care of it, it lasts a long time. And honestly, I probably only use this thing 5 or 6 times a year. It'll probably last my lifetime if I take care of it. The main reason I brought it in was when I bought it, these grease fittings here in the door on each side, they were just pressed into place. They were like barbed grease fittings. And yeah, you can imagine what happened. You'd try and pump grease in and the grease fitting would just eject itself because you have all that hydraulic force from the grease gun. So I drilled those out and put threaded ones in, and that is great now. But I noticed a number of other things in this dump trailer while I had it in here. So the bearing caps on this trailer are this galvanized steel material, and there is a center part that is removable that's a soft rubber plug, and the center of this one is dry rotted away and broken out. I shouldn't be able to stick my finger in there. It also means dirt and debris is probably getting in there, which is no good. There's a grease zerk inside of there, you can see. And here's a wheel that is largely still intact. I think this one, this one's dry rotting as well. It just hasn't fallen out yet. Contemplated 3D printing these, but I don't think this is a good fit for 3D printing. These are such a soft material. I think we would struggle to make a cap out of TPU for this that you'd be able to easily get in and out, because I can get the whole cap out just with my thumb. I can pry it out like that. I don't think we'd have that flexibility out of the durometer of TPU that we would want to print with. So I already picked up a whole bag of these. These were cheap, and they really are a very soft material. And these might even be TPU, just a softer durometer than what we typically work with. So I'm hoping these hold up better than the original. I think these are rubber, but I'm not 100% certain. So if we're not doing this, what are we looking at? Well, let me show you. So this trailer is hinged in the back. The whole thing tips up hydraulically, and it actually, when it's in the down position, it sits on some rubber bumpers, and those bumpers are not looking so hot. Let's tip this up, we'll get a better view. All right, I'll give you a quick peek at it. You can see it's pretty dry rotted. I'm saying quick peek because I do not want to stick my head or hands under here, particularly if I'm holding the camera and paying more attention to what I'm saying than this trailer, because the only thing holding this up right now is the hydraulic fluid in that cylinder. So if our hose fails, if any of the fittings fail, if the solenoid fails, if any number of things fail, that's going to come down in a hurry, and I don't want to be under it. Thing is, I don't know if we can get up high enough to get the safety prop rod in there. Yeah, we're way off. And we're running out of room fast. Maybe, let's see. All right, I think we're pretty much out of space up there. Let's see if we got it. Wow, just enough. Look how close we are up there. What do we have, like 5 millimeters? Let this down a little bit so we are well inside that retaining thing. All right, that's not going anywhere now. All right, I climbed up here to see. So this is after I let it down into that cup. So I think we have about an inch up there now. Yeah, I'll take that win. All right, now that we're safely supported, now we can really see what condition this thing is in, and it's not great. It's pretty rotted, and in fact, it's even coming apart over here. And the weight of the box and whatever's in the trailer actually sits on these. If we look at the way that this is made, so there's a stationary frame. This part, we say stationary, I mean it obviously rolls with the trailer, but it's stationary in that it's not part of the trailer that tips up. If we look at the back, there is 2 plates on the frame, a single tab that comes down, and a big pin that goes through it. That's built so beefy because that actually is supporting the weight of the box and whatever is in the box. This doesn't, when this comes down, there's a gap here. It's not like it's sitting on this frame here. You could see there would be wear on that frame if it was sitting down there. It's not. The load's actually carried on that pin. So the load's distributed between this pin, the pin on the other side, and those 2 bumpers on the front. And if we look at the plate on this trailer, let's see. Yeah, it's rated to carry 8,000 pounds. And the box itself, we don't know exactly what the box weighs, but I think the Yeah, the gross vehicle weight is about 10, okay, so we'll call the weight of the trailer is about 10,000 pounds, and it's rated to carry about 8,000 pounds. If we figure there's around 1,000 pounds in the bottom part and around 1,000 pounds in the top part, just guessing, I mean, we don't have to be exact. That would mean that the box itself, plus whatever we're carrying, could weigh about 9,000 pounds. So that 9,000 pounds is going to be divided up between these 4 points. The bumper there, the bumper here, the hinge there, and the hinge there. So that works out to a little over a ton per corner. Now, yeah, that load's going to vary. It's a live load, right? So as we're going down the road, whatever the suspension doesn't absorb is also going to go into those joints. Now the suspension, I think, is particularly if this thing's fully loaded, is going to absorb a lot of those bumps. But again, it's a live load, so I guess we could see maybe up to 2 ton on each one of these corners. But I think we could say the working load is a little over 1 ton per corner. That's going to matter. Remember that number. All right, let's get one of these off and see what we're working with. It's actually, oh, you know what? I think it's a nylock nut. That's why it's a little loose. Okay, I see why they used a nylock nut on this, because it's tightening down on the rubber itself. Sometimes you see these mounts where there'll be like a steel ring inside here, so that you're tightening down on the steel ring, and then the rubber just kind of goes around the steel ring so that you can't over tighten on the part. This, they just tightened it down until it started to snug up and then stopped. And with a nylock nut, it's fairly safe to say that it's not going to back off. Now, we don't know what the original durometer of this part was, because it's definitely pretty worn right now, which is disappointing. This trailer is only about 5 years old, and it spent most of its life in my barn. It's not even like it's been outside. And even if it was outside, which it was for part of its life, the sun's not really getting to this. So yeah, I think this part might be under-spec'd for the load that it is carrying. I think TPU is going to be a better fit for this. The durometer of this is a little bit softer than TPU. Now, yeah, it's dry rotted a bit, so it might have stiffened up, but I think that's probably countered by the fact that it's got so many cracks in it that makes it easier for it to flex. That, me pushing on this, long way of saying I think the durometer of it is probably still close to the original, because what it's lost in flexibility, it's picked up in cracks. So, all right, let's get some measurements of this. Okay, so I took a whole bunch of measurements there because this part has distorted a little bit. So I'm just kind of averaging those measurements to get a rough idea of what this is. I don't think we need to be super accurate with the dimensions of this, but the other thing I'm noticing is there's this big dent in here on this side. And the other one, let's go look at that other one. Let's go pull the other one off. All right, I don't even need to pull this off to see what's going on. I mean, I'm gonna have to pull it off at some point here anyway, but look at this. This part is actually not the right dimension for this application. It is, yeah, I guess I can kind of push it over a little bit, but it's, the bumper itself is wider than the pad. Yeah, it's not even just the weld there. It's not like they didn't take into consideration the weld. I bet you if I loosen this up and spin it around, it probably sits up on here. So they kind of just shoved it down in there. Hey, little guy. All right, why don't you go ahead and ride my mini bike while we're working on the video. Yeah, I can just pick the material right off of this. This guy was sitting over this corner when it was originally installed, and then just kind of got smushed down into shape, which is why it's all broken apart. So we're actually going to reduce the OD on our part, I think, to get this to fit properly, or maybe put like a step into it. I'm not sure. All right, so I've got the dimensions I need. I'm going to go draw something up, and I'll bring you guys back. All right, and here is the design that I came up with for this. I tried to duplicate the original design as much as possible with 2 changes. So the first change is the overall diameter itself is slightly smaller. I wanted to maximize the diameter because, I mean, that just gives us more material to work with for squish. But I got back some additional space to clear that weld and the side by adding a nice thick bevel to the bottom. I entertained doing kind of like just a step portion, like a kind of like almost like a cutout on the side. The challenge there is TPU is so hard to support. Anytime you use supports with TPU, it is just a giant mess. So I figured, you know what, I'll just knock the diameter down enough, and with a nice fat bevel on here, we should clear. I took the measurement and then I took, I think, 0.5 millimeter off to try and just buy a little extra space so we're not printing 17 of these to get just the right fit. So, all right, I'm gonna print this out at I think probably about 70% infill and see how it goes. All right, our test piece is done, and I'm not super happy with it. I used to print TPU with the sainsmart TPU profile and process slicer on the Mark III's, and it did a pretty good job. I switched over to Orca for pretty much everything, and I used the generic TPU profile. Yeah, it's not great. This seam is pretty nasty. I'm actually worried that that might be a future failure point. I can see it starting to tear. If it's going to tear apart, it's going to do it there. And there's a nasty seam on the inside too, and there's quite a bit of stringing. I looked at the settings for this when I pulled it off the bed. I think we can clean a lot of this up. There's a setting for not crossing the perimeters that was not turned on. I don't know why that would not be on by default for TPU. It is in the old profile I used to use. So we'll turn that on. That'll probably clean up a lot of the stringing. I mean, I did clean it up. It was really bad when I pulled it off the bed, but you can kind of see all the little wispy spots in there still. And I think if we randomize the seam, that is going to eliminate this problem as well. But dimensionally, you can see we're a bit smaller than the original one. Let's try our bolt and washer. Yeah, it's a good fit. Let's see how it looks in the trailer. Yeah, that's a really good fit now. If I kind of shift it all the way over to sort of this edge of that hole, because we have a little bit of wiggle room, there's maybe a millimeter gap there between our bevel and the weld. But if it's in the center, that bevel is right on the weld. So I think we're dead on there. That's looking good, but I think this is way too stiff. And remember I said to keep in mind the amount of weight that we had on each corner. What was it, a little over a ton? I've got a trick up my sleeve that I think is going to allow us to get the overall durometer or the overall flexibility from the original part as close as we can in this part. Let me show you. All right, so if we go over to my hydraulic press, it very conveniently has a gauge on the top that measures in tons of force. And the way they're able to accomplish that is actually given away right here on the gauge itself. It says RAM DIA 60. The RAM diameter is 60 millimeters. So they've done the math to figure out at what pressure this amount of force is exerted. So I think we can exploit this by putting a ton of force on those bumpers and just seeing how much they deform. So let me get the tripod set up here and let's give it a try. All right, I grabbed our rubber bumper that is in the best condition. This is the one that's just a bit deformed on the side, but is not completely splitting apart. So we'll test with this one. I think we could just set the bottom down on like the flat part of one of these plates, but I don't want to try and balance. It's too thin in the middle, and that's going to be really awkward to hold that and put force on it. So let me see if I can find a chunk of steel to put on top here. All right, I found a nice piece of stainless that was scrapped from something else, and I just faced off both sides, so it's nice and smooth and perfectly parallel between both sides. All right, that is 1 ton indicated on our gauge here at the top. So I'm going to take just calipers like this and just get just a rough dimension in there. It doesn't need to be perfect. Okay, so it looks like we are just a little over 14 millimeters on this guy with 1 ton of force on it. Let's try our TPU part. All right, well that is 1 ton on there, and I can already see that gap looks way bigger, but let's measure it. Yeah, that's coming in at almost 18 millimeters. So, all right, I'm going to print another one of these with less infill, and let's try again. All right, less infill this time. Let's see how we did. About 8.5. I think I actually squeezed these a little bit with this caliper, but it looked like it was about 8.6 before it started to move. So yeah, we went way too far. Also, if we take a look at this, the whole thing's flattened out into kind of a pancake. I can't even see the bevel on the bottom anymore, and I'm almost certain that just the head of the bolt and the washer wouldn't even fit in that space. So I think I need to scratch my head a bit on this and think about a better way to do it, because this is not going to work. All right, I came back over to the trailer. I'm taking a better look at all the parts here, and I didn't notice this initially, but you can see the outline of the rubber ring here. But more importantly, take a look at that center part. That's not even just the paint that's worn through. The steel from this plate is actually getting worn through as well from the head of the bolt. So it's definitely compressing all the way down to where the original part is definitely compressing all the way to where the head of that bolt is essentially just hitting against that plate, which is less than ideal because it's, number one, it's a point load, right? So it's just the head of that bolt on this whole plate instead of the outer ring here. But number two, eventually that's going to wear through. I mean, I can feel a pretty good step there now, even before I get to the paint. Like just from the center to the outside, there's a decent step. So I've been thinking about this the wrong way. I was trying to duplicate the original part. I don't think that's the right thing to do. I think I need to take a step back and think about how this really should work. I don't think it's going to be drastically different, but we're not constrained by the dimensions of that original off-the-shelf part. We can design this however we want. Let me go back to the drawing board and I'll bring you guys back. All right, that escalated quickly. I may have gotten slightly obsessed with this, as I tend to do in chasing perfection. So here's our original piece. Here is the first one that we tested. I did forget to mention the second one that I tested when I reduced the amount of infill. Those other changes I talked about, changing the seam to random and turning off or selecting the box for don't cross perimeters. That gave us a substantially better part. That really cleaned it up quite a bit. That's going to be my default settings for TPU in Orca Slicer. But this one ended up being way too soft. So way too hard, way too soft. I could have kept tweaking it to try and get to that butter zone, but I realized, like we saw in that last clip, that the head of this is bottoming. It's bottoming out on that head. It's sort of a bump stop, I guess. Well, not really a bump stop because it's steel on steel. Well before this guy is going to reach the compression amount that we can anticipate for a full load. Now, I don't always carry a full load in that trailer, but given the amount of wear on that plate, I think this one was probably bottoming out on the bolt head well before it was even fully loaded. So I want something that is essentially progressive, that's still kind of soft on the top, but also has enough crush to carry that full load further down. So from this point forward, from this guy here, all these three here are exactly the same dimensionally on the outside, but they are very different inside. I remembered a setting in the slicer that we could use with TPU to sort of get that progressive result that I wanted to get out of these, so that we had basically still soft at the top, more overall travel before we get down to that bolt head, which we partly achieved by dropping that mounting surface down. But I want this guy to stiffen up quite a bit before we do bottom out on that bolt head. So if you want, pause the video right now. Let me know down in the comments what you think I did. And I'm going to show you how this one performs first, and then we'll go up and we'll take a look in the slicer, and I'll show you what I actually did. So let's go back over to the hydraulic press. All right, before I put this in the press, I'm going to give you guys another hint as to what's going on here. It's because it's easier to see the cross section if I squeeze this with some parallel jaw pliers. So here's our original part. Watch if I squeeze this guy, how it's compressing. You can kind of see the jaw digging in down here at the bottom and at the top. Here is our first test piece. Actually, no, I'm sorry. This is the second test piece. This is the one that was too soft. You can see it digs in kind of about the same. We're digging in at the bottom. We're digging in at the top. It's really pretty squishy. And here's our final design. Guys seeing a difference there? Look how soft we are on the top. It's almost like a pillow on the top, but at the bottom, it's barely giving at all, which is what we want. We want this guy to basically be almost like a progressive spring. Watch what happens in the press. All right, so there we go. That's 1 ton of force on there. Do you notice a difference in how this one compressed versus our other test pieces? It's sort of deformed very differently on the top and the bottom. Now, I've already measured this. I know we're good from a gap perspective in here. But let's push this to the limit. Actually, you know what? We don't need this anymore. Let's see what happens when we put 5 tons on this. And then we'll do the same thing with our second test piece, and we'll do the same thing with our final test piece. Okay, so here's our original piece. This is the original rubber bumper that came on the trailer. And we're gonna do 5 tons because I feel like 5 tons is the absolute worst case scenario. That's all of the weight is at a single corner in the trailer and we just hit a big bump. All right, that's 5 tons. I'm letting it off before that thing explodes. So it came back to shape better than I thought. Those cracks are now pretty big. Yeah, this guy's toast. I mean, that probably is what also killed this, is overloading it. I mean, not overloading the trailer, but it just seeing a higher load than that, you know, that 1 ton static load. It being a live load, I think, bouncing on this, although I don't know, because with that bolt head, it's not like this thing could get anywhere near that compressed. I mean, you saw how thin that was. It never would have been able to compress that much with the bolt in there. All right, let's try. Yeah, this is our second, the second one we printed. This one should get pretty darn flat, but TPU is tough. I bet you this guy comes back to the same shape when we're done. Let's see. All right, well, there we go. There's 5 tons. That's actually not that different than the original rubber one. That is pretty darn thin, but I bet you this one comes back to shape. Let's let the pressure off. Yeah, look at that. I mean, I know this one has the advantage of being brand new versus that rubber part that's 5 years old, but it came back to shape perfectly. TPU is really, really tough. All right, let's see what happens when we put 5 tons on our final design. All right, there we go. That is 5 tons, and hopefully you can see. I'll put a side by side up if I can here, comparing the all 3. but that one is holding its shape much, much better. And that is a way, way overloaded condition. All right, let's let the pressure off, see how this guy comes back to shape. Yep, like nothing ever happened. All right, I'm gonna print another one with these same settings and let's get them installed. Oh, almost forgot to actually show you guys how we achieved this. So I'm here in OrcaSlicer and here's a preview of the STL. And if I turn on actual preview of our slicing, you can see on the outside, it doesn't look like anything weird is going on. It looks pretty much as you would expect. But as I cut down into this part in our preview, you can see we have pretty open infill here at the top, and it gets a bit denser. And then down towards the bottom, it gets really dense. So if you guessed that we were going to use height range modifiers on this, give yourself a pat on the back. So if I go back to prepare and you click on objects in OrcaSlicer, same thing in Bamboo Studio, and you right click on the STL, you can add a height range modifier. And I've actually added 3 of them here. So I've tweaked not just the infill, actually. If we look at the bottom, we have 90% infill, and it's actually showing us like kind of a cut there. So this lower part, that is sort of almost our overload part of our, called our spring here. That is where it is going to take a tremendous amount of force to compress this bottom portion because it is 90% infill. So it's going to be quite strong. Now, if we click on the second part, this is what I would call kind of our rated load portion of the compression. So I did 45% infill here. We still have 3 wall loops. That was the same as the bottom section. So from 90 to 45, I mean, obviously that's a pretty substantial jump. This part's going to compress a lot easier and should compress within the normal load range. But if we go up to the very top, you notice it's only 20% infill. This really is meant to be quite soft up here. When the trailer's empty, this is only going to compress a little bit just because we are spreading that load out between 2 of these bumpers. But when this trailer's loaded, this part's pretty much already going to compress, and it's going to kind of act as almost like a catch as we go over bumps or as we set that trailer down or as we start to lift it. This section's going to compress pretty easily. And I adjusted the wall loops down to 2 as well. If you notice, these 2 again were 3 wall loops. This last section here, just that last slice, is 2 wall loops, and I'll show you why. If we go to preview, because we start to hit that curve up here in that same area, having the 2 wall loops is pretty much the same as 3 wall loops further down. Watch, if I hadn't shown you that I had set that to 2 wall loops and I just showed you this preview, you probably wouldn't even notice the difference, because where we lose the wall loop, we essentially start to pick up a top layer from that curve coming in. So I actually made that change not to soften it up. I mean, we realistically could have probably gone down to 1 wall loop and still essentially had at least 2 and would be even softer on top. But I did that just so that we didn't get stiffer just because of the extra top layers that we pick up. In fact, just for the sake of argument, let's set this to 1 wall loop. Slice it again and just see what that looks like. Yeah, look at that. We go from 3 down to 1, which is really still kind of 3. Well, sort of. I mean, it's they're next to each other. It's not. It's a little bit deceiving. Yeah, we go from really like it's 3 there, 3 and a thin, like partial layer, or a thin wall, right back to 3. So honestly, I'm almost tempted to reprint this with with it set to 1 wall loop here on the top. I'm not going to, because the part's already done at this point, but you can see why I knocked the wall loop down for that last section at the top. So that's the trick. I'm familiar with this in PrusaSlicer and in Simplify 3D. This is actually the first time I did it in OrcaSlicer. I knew the feature was there. I did have to go Google how to find it. It's not obvious. If you could click around until you're blue in the face trying to find it here in global and all these other things and support others, there's nothing in here. You've got to go to objects, click on the object, which is pretty easy if you only have one STL in here, and then right click, and you have to be in prepare, not preview. So prepare, objects, plate, your STL, right click, and height range modifier. All right, second one is done. Let's get these installed. just working this back and forth so I can feel when we actually snug up on this. That nylock nut is actually pretty hard to turn, so it's kind of hard to tell. There we go. Just starting to stiffen up. I'm going to give it just a little bit of preload. Yeah, I'm happy with that. Let's do the other side. Yeah, that one is in really, really sad shape. Could probably actually tear that all the way through. All right, I'm happy with that. Let's let this thing down. All right, guys, I think we can call this one done. Not only did we manage to replace those failed pieces, but I honestly think we came up with a much better design. There is significantly more squish that can occur there now before the bolt head actually bottoms out on that plate. And I think this part's going to hold up a lot better than that original rubber part. And, you know, I definitely learned a lesson here. I often approach things, particularly with 3D printing, if I'm making a replacement part, of just challenging myself to try and make the replacement part as close to the original as I can, particularly if I have the original part to work from. But that just wasn't the right thing to do here. I didn't have the same design constraint that the original designer did when they chose that part for this trailer. I mean, I'm sure that's a pretty standard part. And they were limited by the amount of, you know, squish that it had. You know, maybe there's different durometers offered. I'm not really sure. Clearly it wasn't the right size, or the holes were drilled in the wrong place. But that said, the holes were drilled, the distance that the hole was drilled from that side was identical on both sides. If they made if they made an error, they made the exact same error on both sides. Either way, our new part fits, performs really well based on our tests. Unfortunately, I don't have 8,000 pounds of something to throw in here. I thought it'd be neat to end this video by, you know, putting a GoPro under there and actually taking this thing out for a drive, but I can't think of anything I have that is anywhere near 8,000 pounds to load this guy up, you know, without making a big mess of just filling it up with dirt out of my yard to test it. So maybe in the future, if I do use this trailer for something heavy, I'll throw a camera underneath of it and just put up a quick clip on the channel. Guys, as always, thanks for hanging out in the shop with me for this week's design and prints. It's always nice to have you guys along. If you got anything out of this video at all, if maybe you learned about the height range modifiers in the slicer, or, you know, just a little bit more about TPU in general, do me a favor, take a second, hit that like button. Really helps out the channel, costs you nothing except a second of your time, and also gives YouTube an idea of the type of content that you actually like to watch. And if this is by chance your first time here on the channel, we do all functional prints. The STLs are always free. It'll be the same thing for this week's print. The STL for this will be available on my site, fpfdesigns.com. I'll link that down in the description of this video. So feel free to download it and make your own. I'm sure those things are used in all sorts of, not just trailers, but other pieces where a rubber bumper like that is required. Just remember, to get the full function of the design, you're going to need to make those modifications in the slicer as well, so it's softer on the top and stiffer on the bottom. Check out some of the other videos on the channel as well. There's probably one right here for you to click on and check out. If you like that, maybe hit the subscribe button. And guys, if you do, I'll see you next Friday.